Good day. For those of you who don't know us, we're the instructional staff for EC 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to introduce the concept of arrays in C++. So, in this topic, we will describe the limitations of variables that we've already seen. We will introduce local arrays, that is, arrays that are local to a function. We will look at initializing arrays, describe their design and use, and we will look at a number of applications. We will consider consequences of using arrays. So up until this point, we've only had the possibility of having a fixed number of parameters and a fixed number of local variables in any function. Each parameter or local variable must be declared separately. So suppose we wanted to query the user for 3 values and then print out the average. This would require us to declare 3 local variables. Now, suppose we wanted to author a function that calculated the average of 5 values. This would require us to write down this function here that takes 5 parameters and then calculates the average and returns that value. On the other hand, if we now wanted a different function that calculated the average of 7 values, we would have to author a different function that had a different number of parameters. Now, fortunately, C++ is intelligent enough that if you were to declare 2 such functions, then it would simply call the appropriate one that used the number of variables that you were passing as arguments. So, it's okay to actually define multiple functions with the same name as long as they have different numbers of parameters. The problem is, in some cases, we don't know how much data we have or will require, especially if, say, we're reading a sensor, or if, for example, we're describing something where there isn't a fixed number of values. We don't always know how much memory will be required for a particular amount of data that we are trying to store. Like, for example, the number of movies that are in your list of favorite movies may change over time, and if you want to store this on a computer, that may require a changing array size. Now, the logical approach would be to do something that you've already seen in your mathematical and calculus courses. That is the idea of a mathematical sequence. A sequence is just a sequence of values which may be the same or different, but they represent something. Each entry in this sequence of n items, labeled from 0 to n-1, could take on a different value. For example, the first may be the most recent voltage reading from some sensor that your processor is connected to. The next is the next most recent reading, and so on. Alternatively, you may be designing a circuit, which you will be seeing in ECE 140, your course on linear circuits. In this case, you may have n nodes, which are labeled 0 through n-1, and through nodal analysis you can find the voltages at each of those nodes. So we're going to see how we can implement a sequence in C++. Specifically, we will look at arrays. We'll see array declarations, initialization of arrays, accessing array entries, and assigning to array entries. Now, an array of capacity n, capacity is the number of values that it can store, is declared as follows. First, you have the type, then you have an identifier, and that identifier is the name of the array, the same as a local variable may have an identifier name. Next, however, comes square parentheses with an integer value n. The capacity n must be a non-negative integer, so 0 or some other positive integer. The compiler will then allocate sufficiently many contiguous bytes in memory to store n instances of the given data type. Here are a few examples. First, here I have an array of integers specifically 10 of them, and the name of that array is temperatures. The next case, I have an array of 23 doubles, and the name of that array is voltages. Now, the entries of an array store values just the same way as a local variable may store such a value of the given type. We can use these just like local variables. So here, for example, data is declared to be an array of 4 integers. We can access these by using square brackets to store the index, and the indices for an array of size 4 always go from 0 to 3. So this first print statement prints out the 4 entries in this array, although there's no commas between them, so all of the integers will just be jammed right next to each other. The next cout statement prints the sum of the values stored in each of the 4 entries. The indices of an array of size n or capacity n always go from 0 to n minus 1. So if I have an array storing 100 doubles, then I can access each of those 100 doubles by using an index from 0 to 99. Now here's an example of a program that uses an array of capacity 4. What we're doing here is we're printing out each of the 4 entries of the array. However, we will notice that there is no braces following the declaration. As you will remember, for local variables, braces are used for initialization. So what we have here is an uninitialized array of size 4. If we compile and execute this program, we get some rather interesting output. It's only by chance that these first 2 entries are 0 because none of the 4 entries were initialized with any value. So whatever bits, 0s and 1s are there, are interpreted as 4 different doubles. Now, instead of explicitly using literals to access the 4 entries of the array, we can instead use a local variable of type int. So here we have a loop variable k, and as we can see, this loop variable takes on the values 0, 1, 2, and 3. Each time the loop body is run, we access entry k in the array. Thus, if we were to take this program, compile it, and execute it, we would get a similar output to the previous program. It would print out the 4 entries. Once again, by chance, that last entry was 0. These values in this array were not initialized. So next we're going to discuss array initialization. If we want to initialize the 4 entries of the array, we actually have to include a sequence of 4 entries in the braces. So now the first entry of the array, data 0, will have the value 47.2, while the last entry will have 49.4. Thus, if we were to compile and execute this program, we would get an output that prints these 4 entries. To initialize all of the entries in the array to the default value, you can simply use an empty set of braces. This is the same that we used for local variables, except in this case, this will initialize all 4 entries to the default value, and for a double, the default value is 0. So if we compile and execute this program, the output is 4 zeros. What's interesting is that if you do not provide a sufficient number of initial values, here we only have 2 values for an array of 4, then this initializes the first and second entries of the array, that is data 0 and data 1, and all remaining entries are set to the default value. So if we compile and execute this program, we get those two values, and the remaining two values are guaranteed to be 0. Now, if we take a look at this program, we have an array with capacity 4, but there are 5 initial values. Well, unfortunately, this won't compile because it doesn't make any sense. Specifically, the compiler will tell you that there are too many initializers for an array of size 4. Specifically, you've here provided 5 entries. Now, one interesting feature is that the array capacity does not need to be known at compile time. Here, we have a program that queries the user for the number of array entries that are required. We should assume that the user is only going to enter a non-negative number, 0 or greater, and therefore our variable is of type unsigned int. Now we declare data to be an array of that capacity. Fortunately, because the capacity is stored in the local variable n, we can iterate through that array. Now, in this for loop, we are asking for the user to enter each of the entries, and just like we used cin with a local variable, we are now using cin with one of the entries of the array. So, like other local variables, local arrays may go out of scope. In fact, they will go out of scope as soon as the function exits, or even the block in which the array is declared ends. They may or may not be initialized, although in this course you should always be initializing your arrays, even if it is simply to the default value. Now, an array of doubles is not itself a double. So suppose we declare data to be an array of capacity 10. We can use any one entry of that array with an appropriate index from 0 to 9 in, say, an arithmetic expression. However, we cannot simply use data in an arithmetic expression. Data is an array, whereas data 3 or data 7 is a double. Similarly, we can declare flags to be an array of capacity 5, in this case 5 bools or Boolean values, and once again we can use flags 2 in a logical expression, but we cannot use just the array name in a logical expression, because flags is an array, whereas any index into that array is a logical or a Boolean value. Now we're going to look at 4 applications of an array, and we're going to start our program with the following code. In this code, we are assuming that we have an array with n entries where n is greater than or equal to 1. So we're going to ask the user how many entries do we want, and we will assert that n is greater than 0. Data is now declared to be an array of doubles with capacity n, whatever value of n the user entered. All of the entries of that array will be initialized to 0. We will then have a for loop that goes from 0 to n minus 1, and we will query the user for a value for each of these entries. Now, in reality, we're probably not going to do this. Instead, that data may come from a sensor that we're reading, or some other sort of value stored in some sort of other table elsewhere or database. However, this works for now. Now, suppose we were calculating the average value of n entries. Now, in secondary school, you would have labeled these entries as x1 through xn, and the average value of n values is just the sum of those n values, all divided by n. We, however, are now storing those entries in an array in C++. and so these entries do not go from 1 to n, but rather from 0 to n minus 1. So we do have to calculate a sum. We don't know what that sum is, but we're going to add each entry of the array to a local variable sum that is initialized to the value 0. I explicitly want the user to know that I expect sum to be initialized with 0, so rather than just trusting the default entry to be 0, I'm explicitly letting the reader of this code know, yes, I intend for the sum to be initialized to the value 0. I now have a for loop that goes from k equaling 0 all the way up to k equaling n minus 1. With every single iteration of the loop, I add the next entry of the array to my local variable sum. So once this for loop finishes, sum stores all n entries in that array. I now have a local variable declared to be of type double, and it is initialized with sum divided by n. Now, sum is a double, n is an unsigned int, and so therefore n is interpreted as a double, and this calculates the average value of the n entries in this array. So we'll print that to the screen. Next, in secondary school, you may have heard of the standard deviation of some data. So the standard deviation is a slightly more complex formula than the average value, but it isn't that much more difficult. If I have n entries, x1 through xn, what I do is I calculate x1 minus the average value all squared plus x2 minus the average value all squared, and so on and so forth for every single entry I'm calculating the standard deviation for. Having calculated this sum, I divide the result by n and then take the square root. Well, if I wanted to do this with the entries of an array, I would calculate a sum, but I would also have to again start from 0 and go up to n minus 1. So the local variable sum has already been previously declared, so now I'm just going to reinitialize it or assign it the value 0. I now have a for loop that goes from k equaling 0 to n minus 1, but with every single iteration of the loop, I am now adding to sum the kth entry of the array minus the average, all multiplied by, once again, the kth entry of the array minus the average. I can now declare a local variable called standard deviation, which is assigned the sum divided by n, and all of this is passed to the square root function. Of course, I need to include the CMath library to accomplish this. I can now print to the screen the standard deviation. Suppose I want to find the minimum and maximum values stored in this array. Again, remember the user entered in n values, so I don't know what the minimum and maximum are. Let us declare two local variables, minimum and maximum, and let us assume that the first entry of the array, data 0, is both the minimum and the maximum. Now I have a for loop that goes not from 0, but from 1 all the way up to kn minus 1. And so now I'm going to check, is the kth entry of the array less than the minimum? If it is, then I will set minimum to be equal to the kth entry of the array. So if I ever find something smaller than what's currently stored in the local variable minimum, I'm going to update the local variable minimum. If, however, the kth entry is greater than the currently stored maximum, I will store maximum or assign maximum to be the current entry. So once this loop finishes, minimum will have the minimum value of the array, whereas maximum will have the maximum value of the array. So I can now print that the range of the array goes from minimum to maximum. As one final exercise, let's find the maximum entry of the array and swap it with the last entry of the array. Now the last entry of the array is at location n-1. But we don't know where the maximum entry is in the array because we don't know where that entry is. We found what the maximum value in the array is, but we don't know what index that was stored at. So let's start again. Let's assume that the first entry contains the maximum. So maximum has already been declared to be a local variable in the previous screen. So I'm just going to assign maximum to be the first entry of the array. I'm now going to have an unsigned int max index, which is going to store the index of that maximum entry. Now here I have a for loop that steps through each of the entries of the array, and if I ever find an entry of the array that is greater than the currently stored maximum, not only will I update the maximum, but I will also update the index at which that maximum is stored. So at the end of this for loop, maximum will have the maximum entry of the array, and max index will have the index at which that maximum is. We'd like to now swap the index that stores the maximum entry with the index with the entry at the end of the array. So here, temp is initialized with the value stored at the maximum index. I then assign to that value or that index the value stored at the last entry of the array, and then I assign to the last entry of the array the temporary variable which was storing the maximum entry. So once this sequence of 3 statements is run, the last entry of the array now stores the maximum entry of the array, and what used to be the maximum entry stores what used to be stored at the last entry of the array. Okay, so we have now seen 4 applications where we use an array where we got values from the user. So we're just going to return, and you can try to execute this program and see for yourself how it works. Now, the implementation of an array. Here we have data to be an array of 5 entries, and these are the initial values. These are stored in memory, and this memory is where this memory is decided by the compiler. But these 5 entries are stored in contiguous memory. Contiguous means touching. So in one location in memory we're storing 3.7. In the very next location in memory we store the double 4.0, then 2.9, 8.6, and 1.5. And if I was to assign to any of these 5 entries of this array, it would simply update the corresponding location in memory. Also, if I access any of these entries, it will simply access the appropriate location. This may get you thinking. So, what happens if you try to access an entry of the array that isn't actually in the array? Because remember, data was declared to be an array of 5 doubles, and their index goes from 0 to 4. So what happens if you try to access or assign data -1 or data 5 or data some other number? Other programming languages actually check to make sure that you never try to access an entry of an array outside of the bounds of the array. In this case, the bounds of the array are 0 up until 4. C++, however, doesn't really check. It just goes to the corresponding location in memory where that entry would have been if the array was of an appropriate size. Well, actually, an array can never have an index of -1, but nevertheless, if you try to access data -1, it would just access the memory location immediately before where data 0 was stored. And if you tried to access data 5, it would just access the memory immediately after the memory allocated for data 4. The problem is this memory may be allocated for some other reason. So you may be accessing or overwriting memory used for something completely different, like another local variable, or worse, an instruction or something like that. So you cannot access, you should not, you can, but you should not access indexes that are outside the bounds of the array. The problem is C will not do this checking for you, and therefore it's up to you to make sure your code does not exceed the array bounds. One of the most common mistakes is to have a for loop that steps through an array, but instead of starting from 0 and going up until n-1, the loop instead goes from 1 to n. So here we are once again calculating the average value, but instead of looping from 0 to n-1, this for loop starts at index 1 and goes up until k equals n. Let us assume that n was equal to 5. In this case, normally we would expect to sum the entries 3.7, 4.0, 2.9, 8.6, and 1.5. However, if we foolishly looped from 1 to n, we would now be summing these 5 values, and I don't know what's at that last location. It could be 0, or it could be some other number, but it's almost certainly not 3.7. So when this calculation is performed, you will get the wrong answer. It will not be the average value of the 5 entries stored in this particular array. So following this topic, you now understand how to declare an array as a local variable and to initialize its entries. The entries of an array should always be initialized, even if it's the default value. You know how to access and to assign to array entries, and you know that array entries can be treated just like local variables or parameters of that same type. You also know that the array name itself is not an instance of that type. The array name is actually an array, not a double or a bool. You now also know that you can step through the entries of an array with a for loop, and we've seen a number of applications with arrays, including calculating the average value, the standard deviation, finding the minimum and maximum values of an array, and swapping the largest entry of an array with the last entry of that array. Also, you understand that accessing entries outside the array bounds is dangerous. So if an array has a capacity of 7, the array bounds are 0 up until 6, and accessing either a negative index or an index with a value of 7 or greater is going to access memory that is not allocated for that array, and that will cause problems. Here are the references, the colophon, and a disclaimer. Cheers!